Okay. So, like I said, a lot of these topics that we talked about in chapter 1, some of them you have talked about before, some of them you haven't. Some of them you talked about before, and we're just going to go a little bit deeper with it, okay? So, if it's something that you feel comfortable with, okay, or uncomfortable with, I'm going to ask for your participation quite a bit. I'm going to make you talk to each other, and I'm going to make you talk to me. So, be ready. Okay, first thing I want to talk about is, I forget that I have to do this every time, so bear with me. First thing I want to talk about is domain and range. There we go, domain and range. 30 seconds, turn to your neighbor, describe domain and range if you can remember it. All right. Pod 6, you guys are having a good conversation. What'd you say?
So I said that the domain is what you put into the function, and the range is what you get out. So the domain is going to be the x, and then the range is going to be the y.
Okay, so I'm going to highlight a few keywords. You said domain is what you put in. Range is what you get out. Is that what you said? Okay, and then you went on and said, so domain are the x's, range the y's. Okay, how do you feel about what Connor said? I don't know if I could have described it any better than what he just said. Domain goes in, range goes out. Okay, so you guys have done some work identifying domain and range last year in Algebra 2, correct? Okay. So the only thing that's going to be different is the notation that we use. So let's talk about the domain and range of this picture here, and then I'm going to show you our new notation for it. Okay? So let's talk about the domain. Let me use a different color. The domain. Okay? So we're describing our x values. Okay? So do we have x values everywhere? No. Okay? Jackson, where do they begin? Okay, they begin at -1, and they stop where? At 5. Okay. Now, we need to decide, is -1 included or not included? Okay, included, so remember we made that kind of alligator. Is 5 included? Caroline, why not? Okay, we have an open circle, so it's not included, so we make that kind of alligator. Okay. The range talks about the y's, right? So look at, I like to think, x's, we go left to right. Y's, we're going to describe down to up, okay? So if you look down to up, where do we have y values? Who can describe to me where the y values are? Go for it. -3 to 3 is where you said we had y values. Okay? Do we include -3? Yes, because there is a coordinate there. Do we include +3? Yes, because there's a coordinate there. Okay, but it starts at -3, stops at +3. Okay? This is the old notation. You will not write domain and range like this again in this class. Okay? Yay. Right? Okay? We are going to do what's called interval notation. And I don't even care what the back of the book does. I think they do interval notation. Every once in a while they'll throw this notation back, but all the time we're doing interval notation. Okay? So this is what happens with interval notation. Okay? Our old notation, if we had an inclusive coordinate, we would put the underline under the alligator, If it wasn't included, it was just a regular old alligator. Okay? New notation. Brackets are going to be the inclusive. Okay? Brackets versus parentheses means not included. Okay, so I'll give you a little bit to write that down. Okay, don't feel like you have to write every single word up here. You can paraphrase. You can make little chicken scratch notes to yourself. But what you need to know is that brackets mean you include that endpoint. Parentheses mean you do not include that endpoint. And I'll move that up there. Is that better? So let's talk about what this looks like, and then we'll do another example. So our domain goes from -1 to 5. So what we're going to do is we're going to write -1, comma 5. It starts at -1, it stops at 5. Did we include -1 in our domain? Yes. So we're going to put a bracket around -1. Did we include 5 in our domain? No. Not included means parentheses. Okay? So it's going to look similar to an XY coordinate, but it's not. It is an interval. We begin and include -1. We stop and don't include 5. Okay? So our domain is -1 to 5. Our range. Okay? Our range begins at -3 and stops at 3. Since both endpoints are included, they get brackets. So our range is -3 to 3. Okay. So the only new thing is notation. You just have to remember which one is which. Okay, to me, I think that parentheses kind of looks like, you know, kind of like a half circle. Like if you were to draw a circle, it would be like an open circle. That's kind of what I associate with. Okay, if we would make a circle out of that parentheses, it would be open. Okay. All right, so let's look at this example. I want you to take 30 seconds, turn to a different neighbor this time. If there's 3 of you, you can just all 3 talk together. Okay, but turn to a different neighbor and just describe, don't write anything down, but describe the domain and range. Where do we have domain values? Where do we have range values? 1, 2, 3, go. All right, everyone back up here. Let's see, part 4. Describe the domain. Okay, so Gabe described 2 different pieces for me. He said we have values that are less than 1, and we have values that are greater than 1. Would you agree with Gabe? Yes. Okay. Gabe, do we include -1? Do we include 1? Okay, because we have coordinates there. Now, instead of saying x is less than -1, this is how we're going to write it. Our interval goes from negative to infinity to -1. So this means -1 and below. I like to write numbers from left to right. So we're going to begin at -infinity because that's the way to the left side, right? So this basically describes, we start at -1 and it keeps getting smaller. So everything below -1. Since -infinity is not an actual number, we cannot put a bracket on it. Anytime you have an infinity, it has to be in parentheses because we can't include something that's not a number. Okay? So does somebody want to take a shot at how we would write this piece of the domain? Go for it.
Bracket 1, infinity parentheses.
Exactly. We start at 1 and it keeps getting bigger. So including 1 to infinity with a parentheses. Okay? Now, since we have two different intervals that collectively describe the domain, we're going to put a little U in between them to union them. The book won't do this, but I like to. That way you know that those are stuck together. We're unioning those together. They're describing one thing. Okay. All right. I also had you talk about the range, right? So pod 1, what did you describe the range?
We said that the y had to be greater than 0.
The y had to be greater than 0. Okay. So I want you to take 10 seconds and write down what you think that interval is going to look like. Caroline and pod 1 decided that y is bigger than 0. So what do you think that interval is going to be written as? Write it down right now. And then compare it to your neighbor. Okay. Someone from pod 2, what do you have?
I have bracket 0, comma, infinity with the parentheses.
Excellent. Bracket 0, comma, infinity with a parentheses. 0 to infinity. Excellent work. Okay. Function. If I give you a graph, how can you determine whether that graph is a function or not? Talk about it at your table for 15 seconds. How do we determine if a graph is a function? All right. Let's see. Pod 3, have I called on you? Pod 3, have I called on you? I'm sure I have. Pod 3, what's that about?
You can tell if it's a function if the x only equals 1y.
The x only equals 1y. So no x's are repeating or no y's are repeating?
No x.
No x's are repeating. Great. There is a test that you may have been taught. Some test. I think I heard somebody say it in here, but I don't know who it was. The vertical line test. The vertical line test. Draw a vertical line, and if it hits it more than once, is it a function? No. Is this a function? No, because we have repeating x's, which doesn't pass the vertical line test. Not a function. Is this a function? Yes, because it passes the vertical line test. You only see one vertical line drawn here, but we can imagine if we draw lots of vertical lines, it's always going to pass, right? Is this a function? Yes, it is. I guess we should write yes and yes. It is a function. Okay? It is okay to have a gap where it hits no times. That's not against the rule. It just can't hit more than once. Okay? Okay. Something else to talk to your neighbor about. You're going to get to talk a lot today. Okay? Finding zeros. What does it mean? If I said, hey, find me the zeros of this equation, what does that mean? 30 seconds. Go. Okay, pod 5. I have not picked on you. That would be you 3 men right here. What does it mean if I say find zeros?
You find where the function touches the x-axis.
We are finding where the function touches the x-axis. Do you agree? I'm getting some head nods. Yes, I agree. Okay, so in short, I'm going to call those x-intercepts because I don't want to write that long sentence that you just said. Okay, I'm going to take a little shortcut there. I did hear some people describing how to do that. Would anybody like to offer up their description of how to do that? Jackson?
Well, I mean, if you're not looking at a physical graph, you can see where it hits the x-axis. You can take the function, and if you're looking for the y-intercept, you plug in x through 0. And if you're looking for the x-intercept, you solve the function for 0.
Okay, so if I were to give you an equation like this, and we wanted an x-intercept, okay, on the x-axis, I'm going to come back here. Anytime we are hitting the x-axis, what is the y value? 0. So if I give you an equation, we're going to plug 0 in for y. Oh my goodness, I don't see y. What does the y mean the same as? As the x. Okay, what are we going to have to do with that? What? I want to, okay. Factor. Okay. Now, we all have different ways that we learned how to factor. Here's the deal. We're in honors for calculus. Okay? You know how to factor. I don't know how you learned it, but anytime I do it up here, we're going to follow patterns and just fill in these and check them, okay? I kind of call it guess and check, but we're we're doing some educated guessing and checking, okay? To get 3x squared, we need a 3x and an x. To get negative 16, we're going to have to pick two numbers and multiply to be 16 here. Okay? Any suggestions? 4 and 4. One has to be positive, one has to be negative, right? So here we get 12x, and here we get negative 4x. Does that add up to be 22x? Sure doesn't. Well, you know what? We tried. We're doing math in pencil. We can erase. 2 and 8. Okay? One has to be negative, one has to be positive. What's 3x times 8? 24x. And negative 2x, do those add up to be 22x? Awesome. Like I said, if you want to factor a different way than what I'm doing, go for it, but this is how I'm going to do it up here, okay? So, we have 0 is 3x minus 2, and 0 is x plus 8. Set each factor equal to 0. X is 2/3. And x is negative 8. There are our zeros. If we have time at the end of class, I will show you how to do this on your graphing calculator, okay? But I need to squeeze in a couple more things before lunch, so we're going to keep going. All right? The next thing we're going to talk about, increasing and decreasing, okay? So I'm going to give you graphs, and we're going to have to determine where our graph is increasing and where it is decreasing. Okay? So when we think of increasing, what are some words to describe increasing? Rising, going up, okay? Decreasing. Ascending, going down, getting lower, okay? How do we read words? Left to right. How do we read graphs? Left to right. Okay, so as we go left to right, what's happening with this little piece of the function? It is decreasing. So I can say that my, gosh, dang it, that's not a good color to use. That my function is decreasing. This is -1, -2, -3, -4, -5. My function is decreasing from -5 to -3. Now, why am I using parentheses? At -3, can we say that it is increasing or decreasing? It's changing directions, right? Okay, so we're going to use open intervals for increasing and decreasing. Now, do you notice how I use the x values? We're describing the piece of the domain that is decreasing. Okay? All right, so we got to -3, and we're done decreasing, right? Then what happens? We're rising, we're increasing. So I'm going to describe that we are increasing when x is -3 up until x is 0, because that's where it switches directions. Okay? And then we have an interval where we're doing what? We're decreasing from x is 0 to x is 3. So I'm going to attach that interval onto my decreasing. Okay, and then we have another interval where what's happening? We're increasing from x is 3 to x is 5. Okay? From left to right, we read our graph, and we always describe the piece of the domain that is increasing or decreasing. The y values don't matter right now. Okay? Now, it also says determine intervals where the function is increasing, decreasing, or constant. With your arm, show me what it would look like if our function was constant. Okay. Like this. Excellent. Okay, just straight across. We could walk on it, right? Okay. Now, along with increasing and decreasing intervals come what we call minimums and maximums. Okay? Minimums, we think of what kind of a number? Okay, small. I'm going to say low when you're talking about graphs. Maximum, high. Okay? We're going to talk about relative minimums and maximums. Okay? If we were talking about minimums and maximums, we'd be talking about like highest point and lowest point. I don't really want that. I want relative minimums and maximums. And a relative minimum and maximum is basically where our function is switching directions. Okay? If we switch from increasing to decreasing or decreasing to increasing, we're creating either a minimum or a maximum. So I'm going to let you paraphrase anything you want to write down, and then we're going to look at the graph from before, and I'll show you what that looks like. Okay? So everybody watch my hands here, okay? We either are going from increasing to decreasing, or we could switch from decreasing to increasing, okay? If I'm going from increasing to decreasing, do you think that's going to be a maximum or a minimum? and I'll show you on the graph. I know I'm like dancing with my hands here. And then decreasing to increasing, that's going to be a minimum. Okay, so I'm going to go back to the graph. So do you see here how we go from decreasing to increasing? Do you see that? That means this point right here is a relative, fill in the blank, minimum. So we have a relative minimum at the coordinate -3, 0. Is there another relative minimum on this graph?
3, -3.
3, -3, excellent. Okay. Do we have a relative maximum? Yes, who said yes? I heard a yes. I heard a girl yes. You were a girl yes. Okay, where is it?
0, 3.
At 0, at the coordinate 0, 3, we're going from increasing to decreasing. Okay. Like I said, I'm going to hold off on the calculator for right now. At the beginning of each chapter, I'm going to give you basically an agenda. Okay? This is called your goal sheet. Every chapter there will be goals. On the front, you have every single assignment and when they're due. On the back, those are the objectives that you need to be able to master before taking a test. Okay? And I'll talk about more about those objectives at a later time. What I want you to focus on right now is the front of this. Do you notice how things are bolded and underlined and some things aren't? I want you to do every single problem I have listed here, but bare minimum, you better do those bolded problems. Okay? If you've done the bolded problems and you need more work, okay, there's more problems there for you. If you've done the bolded problems and you're busy or you really have a good handle on it, you've done the bare minimum. I don't think you should do the bare minimum, but I'm putting that ball in your court. Okay? You see where it says 8 basic functions charts due on Monday? That is this right here. Over the course of today through Sunday evening, you need to fill out this chart. There are 8 basic functions that we are going to discuss, and you need to know what they look like before Monday because we're going to do an activity with them. Okay? So this pink sheet is due on Monday so that you can participate in our activity. So you see that you have homework for today. It looks like this. It's on your gold sheet. What happens if you lose your gold sheet? Where can you find homework? On my website, I have a calendar. Okay, it is time for lunch. You may go, and when we get back, we'll talk about the summer packet.